Introduction. Many people talk about freedom when it comes to Linux, but I believe most don't fully understand what this freedom truly means. Freedom is having the power to decide what your computer does, and the only way to possess this freedom is by knowing what your computer is doing. Freedom is owning a computer without secrets, one where everything is accessible if you're willing to explore. Why use the command line? It's often said, GUIs make easy tasks easy, while command line makes hard tasks possible, and this holds true today. Since Linux is based on Unix, it has inherited a strong tradition of command line tools. Unix rose to popularity in the 1980s, well before GUIs became common, so it developed a vast set of command line tools instead. This powerful command line capability is only one reason many early Linux users chose it over systems like Windows, because it made those hard tasks possible. Part 1. Learning the shell. What is the shell? When we talk about the command line, we're really talking about the shell. The shell is a program that takes the commands you type and passes them to an operating system to get things done. Almost all Linux distributions come with a shell program from the GNU project called Bash. Alright, let's get started. Launch the terminal. Once it comes up, you should see something like this. This is called a shell prompt, and it appears whenever the shell is ready to take your commands. The exact look of the prompt might vary a bit depending on your Linux distribution, but it usually includes your username at machine name followed by the current working directory. If you see a hash mark instead of a $sign, the session has super user privileges, meaning you're either logged in as the root user or you've launched a terminal with administrative access. If everything's set up so far, let's try typing something. Enter some random gibberish in the prompt like this. Since this command doesn't actually exist, the shell will let you know with a message, command not found. And then it'll return to the prompt, ready for you to try again. Command history. If you press the up arrow key, you'll see that the last command pops up again after the prompt. This feature is called command history. By default, most Linux distributions remember the last 500 commands you entered. If you press the down arrow key, the command disappears, taking you back to a blank prompt. Try recalling the last command with the up arrow key again. Now use the left and right arrow keys. Notice how you can move the cursor around on the command line? This makes it super easy to edit commands without having to retype the entire line. Now that we've practiced typing, let's try a few simple commands. The first one is date, which displays the current date and time. To check the available space on your disk drives, use the df command. Similarly, to see how much free memory is available, use the free command. These commands give you quick insights into your system's current date, disk space, and memory usage. Ending a terminal session. You can end a terminal session in two ways, either by closing the terminal window or by typing the exit command at the shell prompt. This will close the session and return you to your desktop. Pro tip: avoid using Ctrl-C and Ctrl-V for copy and paste in a terminal window. They won't work as expected. In the shell, these key commands have special functions that were set up long before Microsoft Windows introduced copy-paste shortcuts. The current working directory. Most of us are familiar with the graphical file manager, where the file system tree is displayed, like in Figure 2.1. You'll notice that it's usually shown upside down, with the root at the top and branches extending downward. When working on the command line, though, there aren't any pictures to guide us, so we need to picture the file system a bit differently. Think of it like a maze shaped as an upside-down tree, where we're standing in the middle of it. At any moment, we're inside a specific directory, known as the current working directory, and can see the files inside it, the path to the directory above, the parent directory, and any subsequent directories below. To find out our current location in the file system, we can use the pwd print working directory command. When you first log into the system or start a terminal session, your current working directory is set to your home directory. Each user account has its own home directory, which is typically the only place where a regular user can save files. Pro tip: keep in mind that unlike Windows, where each storage device has its own file system tree, Unix-like systems such as Linux always use a single file system tree. No matter how many drives or storage devices are connected, everything is a part of this one unified structure. These storage devices are connected or mounted at different spots on the tree based on the preferences of the system administrator, the person or people who maintain the system. Listing the contents of a directory. To see the files and directories in your current working directory, you can use the ls command. Actually, you can use ls to list the contents of any directory, not just the one you're currently in. Plus, ls has a bunch of other handy options that make it even more versatile. We'll dive deeper into all the cool things ls can do in Chapter 3. To change your working directory, where you're standing in the tree-shaped maze, use the cd command. Just type cd, followed by the path name of the directory you want to move to. A path name is the route you want to take along the tree branches to reach your desired directory. There are two ways to specify path names: absolute and relative. Let's start by looking at an absolute path name. An absolute path name starts from the root directory and follows each branch of the tree until it reaches the desired directory or file. For example, there's a directory on your system where most of the system programs are installed, and its path name is /usr/bin. This means that from the root directory, represented by the leading slash, there's a directory called usr, which contains another directory called bin. Now, we've changed our current working directory to /usr/bin. Notice how the shell prompt is updated. By default, it's set to conveniently display the name of your current working directory. Relative path names. While an absolute path name starts from the root directory and leads directly to the destination, a relative path name begins from your current directory and uses special symbols to represent locations in the file system. These symbols are dot and dot dot. Dot refers to the current working directory. Dot dot refers to the parent directory of the current working directory. Here's how it works. First, let's change the working directory to /usr/bin. Now, if we want to move to the parent directory /usr, we have two ways to do it: with an absolute path name or with a relative path name. Both methods work just as well. Choose whichever one requires less typing. We can also move from /usr back to /usr/bin in two ways: using an absolute path name or with a relative path name. An important tip: you can almost always skip the // since it's implied, so typing will work the same way. In general, if you don't specify a path name, the shell assumes you're referring to the current directory. Here are a few shortcuts to quickly change your current working directory. If a file name begins with a dot, it's considered hidden. This simply means that the ls command won't list it unless you use ls-a. When your account was created, several hidden files were placed in your home directory to configure your environment. We'll take a closer look at some of these files later on to see how you can customize your system. Additionally, many applications store their configuration and settings files as hidden files in your home directory. Case sensitivity. In Linux, just like in Unix, file names and commands are case sensitive. That means that file 1 and file 1 are seen as two completely different files, so be mindful of capitalization when working with files and commands. File extensions. Linux doesn't use file extensions to determine a file's type like some other operating systems do. You can name your files however you like. The content and purpose of a file are determined by other means. Although the system doesn't rely on file extensions, some applications might, so it's good to be aware of that. It's best to limit punctuation to periods and dashes and underscores in the file names you create. Most importantly, try to avoid using spaces in file names. Spaces can make command line tasks more complicated. If you want to separate words in a file name, use underscores instead. You'll thank yourself later. Part 3. Exploring the system. Now that we know how to navigate the file system, let's take a guided tour of our Linux system. Before we dive in, here are a few more commands that will be helpful along the way. These will make it easier to explore and understand what's inside each directory as we go. The ls command is one of the most frequently used commands, and it's easy to see why. With it, we can view directory contents and find important details about files and directories. Here's a quick look at some of the ways to use ls. To simply list files and subdirectories in your current working directory, we can type just ls. You can also specify another directory to list like this, ls/usr. Or, if you want to list multiple directories at once, you can. Here's an example using the contents of both the home directory and /usr directory. For even more detail, try adding the -l option to change the output to long format. By adding -l to ls, you get a more detailed view of each item, including permissions, ownership, file size, and last modified date. Options and arguments. This brings us to an important point about how most commands are structured. Commands are often followed by options that adjust how they behave, and arguments that specify what the commands will act upon. So, most commands follow this general structure. Many commands use single character options like -l, which are typically preceded by a single dash. Some commands, especially those from the GNU project, also support long options, which are full words preceded by 2 dashes. Additionally, multiple short options can often be combined. For example, in this command, ls-lt. The ls command is given 2 options, -l for long format and -t to sort by modification time. You can add the long option --reverse to reverse the order. The ls command has a range of options. Here are some of the most common ones. These options allow ls to be customized in many ways, making it a very versatile command. Question: how could we shorten the earlier command ls-lt-reverse? ls-ltr. A longer look at long format. When using the -L option with ls, the output displays a lot of detailed information. Here's an example output. Let's break down what each part means. Access rights to the file. The first character indicates the file type. A dash means a regular file, while a D would mean a directory. The next 9 characters show permissions for the owner, group, and others. 1. Number of hard links. Username of the file's owner. Group name that owns the file. File size in bytes. Date and time of the file's last modification. As we explore the system, it'll be helpful to know what kind of data each file contains. We can use the file command to determine a file's type, since file names in Linux aren't required to reflect their contents. For example, a file named picture.jpg might suggest it's a JPEG image. This isn't actually enforced by the system. To use the file command, simply type file name. The command will give a brief description of the file's contents. There are many types of files in Linux. In fact, one of the more core ideals in Unix-like systems is that everything is a file. We'll see just how true this is as we continue. While some files like MP3s or JPEGs are familiar, others may be less obvious or even a bit unusual. What is text? On computers, information can be represented in many ways. Essentially, all data is converted to numbers, as computers only understand numeric representations. Some formats are complex, like compressed video files, while others are simpler. One of the earliest and simplest is called ASCII text. ASCII stands for American Standard Code for Information Interchange, and it provides a straightforward way to map characters to numbers. Each character corresponds to a specific number. This method is compact, as 50 characters of texts equal 50 bytes of data. It's different from the text in a word processor document like Microsoft Word or OpenOffice, which contain additional elements for structure and formatting. Plain ASCII text files, however, only contain characters and a few basic control codes like tabs and line breaks. In Linux, many files are stored in text format, and a wide range of Linux tools are designed to work with text files. Even Windows recognizes the importance of this format. The Notepad program, for instance, is an editor specifically for plain ASCII text files. The less command is used to view text files like this. Once less is running, you can scroll through the file both forward and backwards. For example, to view the file that defines the system user accounts, you can type. With less open, you can view the file's contents, scrolling up and down if it's more than a page long. To exit less, press the Q key. Less is more. The less program was created as an improved replacement for an earlier Unix program called more. Its name is a clever play on the phrase less is more, a motto popularized by modern architects and designers. Less belongs to a category of programs known as pagers. These programs make it easy to view long text documents, one page at a time. Unlike more, which only allowed you to move forward, less lets you move both forwards and backwards through a file and comes with many additional features for easier navigation. A guided tour. The file system layout on your Linux system is quite similar to that of other Unix-like systems, following a structure specified in the Linux file system hierarchy standard. While not all Linux distributions follow this standard exactly, most adhere to it closely. Now, let's explore the file system to see how our Linux operating system operates. This will give you a chance to practice navigation. You'll find that many of the important files are in plain, human-readable text. As we take this tour, try the following steps. Use CD to enter a specified directory. List the contents with ls-l to see details. If a file catches your eye, check its type with File. If it appears to be a text file, view it with Less to see what it contains. This approach will give you insight into the inner workings of your system as you navigate. As we explore, don't worry about looking at different files and directories. Regular users have limited permissions, so it's pretty hard to accidentally break anything. That's the system administrator's responsibility. If a command doesn't work, or you get a permissions error, just move on to something else. Take your time looking around. This system is yours to explore. In Linux, there are no secrets.